Have you ever wished that you could slash your energy bills and shrink your carbon footprint, all while letting your home learn how to optimize itself? In this video, we'll explore deep reinforcement learning and show you how to design smart home energy management systems using EdrawMax. Stick around for a real-world case study that proves just how powerful this approach can be. Hello, Edrawers, and welcome back to our channel, where we combine cutting-edge technology with practical engineering. Today, we're diving into the world of smart homes, specifically how to optimize energy consumption. We all know energy costs are on the rise, and sustainability has never been more important. By harnessing AI, especially deep reinforcement learning, we can teach our homes to manage appliances, HVAC systems, and even renewable energy sources intelligently. So what exactly is deep reinforcement learning? Think of it as a learning process where an agent interacts with an environment, your smart home in this case, by taking actions and receiving rewards. Imagine you have a smart home that learns how to save energy and keep you comfortable. Let's break down the deep reinforcement learning mechanism. First, we have agent. In a smart home, the agent is like the software or control system that decides what to do. It could be running on a small computer like an Arduino or Raspberry Pi. The environment is second, and it's everything in the house that the agent can affect or measure: rooms, lights, temperature, and appliances. Then there are actions. Actions are the things the smart homes can do based on what's needed, like turn on or off lights, fans, or the heating and cooling systems. States are the real-time conditions the agent sees, the current temperature if the lights are on, and these observations decide which action to take. The reward tells the agent how well it did. For example, if the smart home uses less electricity, it gets a positive reward. If it wastes energy, it gets a negative reward. The twist here is deep learning, which uses neural networks to handle more complex decisions. This means your home can learn from patterns of occupancy, weather changes, or electricity rates, then automatically adjust devices to minimize cost and maximize comfort. Now let's see how DRL can transform your home into a smart energy hub. First, HVAC optimization. Instead of setting a static temperature schedule, a DRL agent learns the best times and temperatures to heat or cool your home, balancing comfort and energy savings. Appliance scheduling. Number 2, appliance scheduling. Why run your dishwasher or washing machine during peak hours? DRL can analyze usage patterns and electricity tariffs to schedule these tasks when energy is cheaper. Number 3, renewables and storage. If you have solar panels or battery storage, DRL can help decide when to store energy and when to feed it back into the grid, maximizing cost savings and reducing reliance on external power sources. To bring all these ideas together, let's talk about EdrawMax. EdrawMax helps you design and visualize complex systems. Whether you're mapping out an Arduino-based circuit or sketching a high-level DRL flowchart, EdrawMax will let you improve your design process. This step-by-step guide will help you design a clear and professional wiring diagram. Step 1, open EdrawMax and choose a template to get started. Open EdrawMax and click on New. From there, select Electrical Diagram to start making your home automation diagram from scratch. Or if you want to get a head start, you can find a variety of templates for wiring diagrams. For this tutorial, we'll start from scratch, but feel free to explore the templates if you want. Step 2, add components to your diagram. So we're now on a blank canvas, and to start creating our wiring diagram, we first start by looking for the components we need. We can click on the symbols icon on the left side of the screen, and we can see a library of symbols. Look for the necessary electrical symbols you need. For a smart home automation project, you might include components like motion sensors, smart lights, and a control center. Then add a visual representation of the deep reinforcement learning model to the design. This model is trained on TensorFlow on a computer and then runs on the microcontroller. Click Add to My Workbench to add it to your symbol library. Next, you can simply drag and drop the components you need onto the canvas, and then it's time to connect the components. Click on the connector icon at the top of the screen, or use the round dots on each component to drag and create connections. Make sure to follow the logical flow of your system. Step 4, label and organize your diagram. Label each component and connection to ensure clarity. For instance, label the pins on your Arduino or the type of wire being used, for example, 12V, ground, etc. And you can also use different colors or line styles to differentiate between power lines, data lines, and control lines. Step 5, save and export. Once you have completed the wiring diagram, you can actually save it for later edits or online sharing. To save a file, click on File, then go to Export and save it as commonly used file types such as Excel, Word, or PDF. Now let's take a look at a real-world example of how deep reinforcement learning, DRL, can be applied to home automation using hardware like an Arduino, relays, sensors, and a learning algorithm like PPO, Proximal Policy Optimization. Let me break it down into two main sections, the environment and the DRL agent. Let's start with the hardware side of things. One, Arduino Uno. The Arduino Uno acts as the central microcontroller. It reads inputs from sensors and controls output devices like lights and fans. Second, IR sensors. The IR sensor is used for detecting any presence or movement. It could represent human presence as well. When it detects a presence, the IR sensor sends this state information to the learning algorithm to process the information. 3, Bluetooth module. The Bluetooth module enables wireless communication, for example, receiving user commands or sending sensor data to a mobile app. This serves as a bridge between the Arduino and external apps or the DRL system. Number 4, relays. 12 volt. The relays are used to switch high power devices like a bulb and fans. These relays are controlled by the Arduino using transistors. Now let's talk about the intelligent AI agent that is controlling the entire system. Think of the deep reinforcement learning algorithm like an AI brain. It receives state information from the environment, like sensor readings, and based on its learning, it sends back actions to control devices, which in our case is the Arduino Uno. It also receives a reward signal to learn whether its last decision was actually good or not, and improves over time, which I think is pretty dang cool. For more wiring diagram examples, visit our template community. Check out the link in the description down below. As AI and machine learning continue to evolve, expect even more sophisticated and user-friendly solutions for home automation. Improved DRL algorithms will handle increasingly complex tasks like coordinating multiple energy sources, predicting maintenance needs, and even adapting to lifestyle changes. Before we wrap up, let's revisit our main takeaways. 1, DRL can dramatically reduce energy costs and environmental impact. 2, EdrawMax streamlines the design process, making complex system planning more accessible. 3, the future of smart home energy management is all about intelligent adaptation, learning from real-world data to optimize comfort and efficiency. If you found this video helpful, please like, share, and subscribe. Check out the description below for links to EdrawMax, additional tutorials, and other resources. Thanks for watching, and we'll see you in the next one.